Hi, my name is Piotr and I work here at Zmorph as a product expert. Today I will show you, in a series of videos, why Zmorph is the best all-in-one 3D printer on the market, how easy it is to use it, what kind of materials it can process, and how it can change your desktop into a workshop. Along with the premiere of Zmorph Fab, we also worked on upgrading our dedicated software Voxelizer into 3.0 version. It comes now not only with more user-friendly UI, but also with fixed stability and performance. Let's see how it works. We will start with selecting proper setup for Zmorph Fab. So as first, select Zmorph Fab, then choose the toolhead from the list. In this situation, it will be CNC milling toolhead. And after that we can press start, since there are no additional options. Now we are in the CNC milling workflow. First thing that we always have to do is to import the file that we want to work with. I will import the example file for this video. This workflow can operate on 3D models, as well as on 2D files like the XF paths. To import the file, press big button Import Model on the center of the workspace. This video will be about 3D milling operations, so I will import the STL file. After loading the model, we can see that the model is in the wrong position. The software also tells us that the model is too big for this workspace. I need to transform the model. I will rotate it to place it on the bottom face of the boat. To do that, I can use the Scene Mode transformation tools. Let's take a look how is it placed now. I can grab and drag the model to the position I want it to be at. Let's take a look on the stock, which is the yellow box around the model. This is a virtual representation of our material that we will mill to get the model. We can set the stock in two ways. First is the relative box method. In this method, the box adapts to the size of the model. I will scale up the model now to show you how it works. You can also set an offset to add extra stock around the model. Let's scale the model to the original size. Second method is the fixed size box. In this method, we simply set the size of the stock by giving the values and setting the position of the model inside the stock. I will change back to the relative stock since it fits me now. Here, in the scene mode, we also set so-called local coordination system. This is nothing else than the spot where we will physically set the zero position of the toolhead before we start the work. In regular practice, we set the coordination system to the left front top, and it will be set as shown on the video. Now, when everything is set, we can move on to the settings section. Press the button named Next to proceed. This is the settings mode. Here we can set the settings for 3D milling operation. Looking from the top on the settings column, the first parameter to set is stock material. In this parameter we set what kind of material we have mounted on our CNC work table. We can either choose from the wide range of presets materials or add our own by clicking on See More button on the bottom of the list. Here we can duplicate the existing preset or add new one by using Add New Preset button. We can name the preset and set our own parameters. Then we can go back to the settings and select the new preset from the list. But in this example I will go with Wood preset, as I'm planning to mill in the wood. Next parameter is a toggle option that shows or hides an outline of our stock material. Turning it on might help us with visualizing what is going to happen during the milling operations. Next one is safe elevation. It tells the toolhead how much it has to rise for jog operations to make sure that it won't hit anything on the workspace during the movement. I will leave it as it is on default for safety. First milling operation that we will use is a face milling. This operation allows us to prepare raw stock surface for machining. This operation removes material from the top surface of the stock to the top of the model to remove roughness. At first, I choose the operation, then I select the face contour. In this example, it will be the stock, and we press continue. New settings will appear. We will leave the starting height and final depth as it is. Before we proceed, we can take a closer look on the model. Green rectangle is the start of the process and blue one is the end height of the process. In this kind of operation, whole material between those two rectangles will be removed. Press continue. After that, we have to select the end mill that we'll use for this operation. After selecting it, the software will show us the toolpath. Red lines are the lines where the milling will happen, and the blue ones is the jog movement. Also, we'll get some more parameters that we can set, but for this example, we will stay with the default ones. When everything is set, simply press apply. Now the operation will appear on the operations list. Clicking on it will show us how it looks like by the toolpaths. We can add another operation by clicking Add New Operation button. Now I will choose Adaptive as the next operation. This operation is very effective in clearing the stock. The process is divided into two stages: roughing milling to remove the most of the material, and then the final milling to give us the good fine quality of the surface of the millet model. Let's select it and then select the adaptive contour to stock and press continue. Now we'll set the starting height and final depth. Remember that we removed the material from the top to the model with the face milling operation. So we set the starting height to the top of the model. Now we can set the final depth to the bottom of the model. Now press continue. Then select the operation tool. After selecting it, we will get the toolpath for this operation with this tool. For new users, this might look messy and hard to understand, but after few milling it will get more clear. In this operation we can see that it's also made in layers. We call that step down. In default, each step down is 1 mm at max. While milling softwood, we can safely change it into 2 mm. There will be less steps and milling will end faster, with the same result. We can move on and press apply to add the operation to the list. Now we will use a parallel milling operation. This is the operation that we mainly use as a finish operation after adaptive milling. Select it and then select the surface to cut. It will be our entire boat. Select it and press done, then continue. Now we select the starting height and final depth. It will be the same as in the operation before. Starting height as top of the model and final depth as bottom of the model. Now press continue. Now select the operation tool. This operation takes a bit of time before the software generates the paths. We will apply it now and wait for software to generate them. In operation list we can see the parallel operation and the progress bar. We have to wait till the software finishes. When it is done, we can select the operation and see how it looks. For the next operation, I have to change the example model. Those two next operations need a model where the software can detect the arcs or circles to set the center point. This simple example model let me show you how to use those operations. Select the spiral operation and press select button for the center point. On the model you can see there is a spherical pocket. Software have already set the center point of this pocket and marked it as a black point. I have to select this point and press done. Now I press continue. Now I set the starting height. Normally, I would do the face milling first, to remove the material between the stock and the model, but since this is just an example, I can skip it, so I will choose the top of the model as our starting height. The material depth is a little bit tricky here. Let's choose top of the model as well and set the offset for minus 25 mm, since I know that the pocket will have a radius of 25 mm. Now, press continue. Select the operation tool. Now you will see the toolpath, but it does not cover the whole pocket. It is because we have to change the default setting called outer limit. It defines how far from the center point the milling will go. If I change it to 25 mm, the same as the radius, the milling will cover the whole pocket. From top we can see how the milling will go. Press apply to add the operation. Now, let's move on to the next and final operation, radial milling. In this operation, we also have to choose the center point as in the operation before. Select it and press continue. Now, we select the starting height and final depth as same as before, top of the model in both positions, and we set minus 25 mm of offset in final depth. Now, press continue. Choose the operation tool. Now, in this operation, we also have to select the range of milling. So, we have to set the outer limit to 25 mm. After a while, we'll see the result. Another thing that we can set is the axial direction. If we want to mill from the inside to outside or in opposite. Let's apply the operation. Now I will load the boat again, and we will see how the simulation of milling operation works. I will add a face milling operation. From the top of the stock to the top of the model. I will change the max step down to 2 mm. In softwood, it is a safe value. Let's apply the operation and add a new one, which is adaptive milling. Select the adaptive contour as a stock. Start is top of the model and final depth is the bottom of the model. Now, press continue. Here, I will also change the max roughing step down to 2 mm. Now I will apply the operation. Now I can go to simulation. After we enter it, the software will automatically generate us the visualization how the part will look like after milling. We can also see the animation of entire milling. To see it, press play button. Play speed can be also adjusted. If we are happy with the process and the outcome, all is left is to press next. After G-code is ready, we can save it on SD card and play on the machine.